All right, hey guys, I got a request to do some example problems for you from the worksheet. So let's do a few of these together. Um, so the first thing you guys will do is list out which elements you have on each side of the equation. Now, here on the left side, you draw those columns through the arrow. On the left side, I see I have K, which stands for potassium. I have B, which is boron. And I have O, which is oxygen. Can you see that? Yeah. Now, if I look on the right side, I should have the exact same elements. I have potassium, correct. I have boron, correct. And I have oxygen, correct. And that's everything that's accounted for. So now we can just get to counting these elements and balancing out what we need to. How many potassiums do I have? Well, I have 1 times 1. I have 1 potassium. How many potassiums do I have on the right side? I have 1 times 2. That's 2 potassiums. How many borons do I have on the left side? I have 1 times 2. That's 2 borons. And on the right side, I have 1 times 1. It's 1 boron. On the left side for oxygen, I have 1 times 3. That's 3 oxygens. And I have 1 times 1. That's 1 oxygen. So as you can see, anytime something's not filled in, like a subscript or the coefficient, you can just write 1 there. Assume it's a 1 to start with. And then we can start changing these coefficients, not the subscripts. We can change the coefficients to start balancing the equation out. So I can see potassium here. I have the lowest number of potassiums here on the left-hand side, so I could change this coefficient. But potassium is by itself, and typically when something's by itself, it's good to save for last. Boron, same issue. I don't want to start with boron, so I'm going to start right here with oxygen. Just so you guys know, I haven't solved any of these before, so I'm showing you guys my thought process on my first time solving these things. So oxygen. Let's change this coefficient to give ourselves a same number of oxygens. I have 3 oxygens on the left. I know that if I change this coefficient to a 3, I'll have 3 times 1 oxygens. I have 3 total oxygens on the right side, but that doesn't just change my oxygens, it changes my potassiums. So now I have 3 times 2 potassiums, so I have 6 total potassiums on the right hand side. Now I'm going to go and balance my potassium, because I balanced oxygen, boron, and potassium are the things that are left to balance. I have less potassium on the left hand side, so I will fix this. I will change this coefficient to give me 6 potassiums, and I know 6 times 1 is 6. So I just balance my potassiums. Now for boron, I know I have 2 borons on the left-hand side, and I want 2 borons on the right-hand side. In order to do that, I have to change this coefficient from a 1 to a 2. And that gives me 2 times 1. It gives me 2 total borons. And that's my answer. If I have the potassium's balanced, boron's balanced, oxygen's balanced, if I try to reduce this, I can't, because you can't divide all these by 2. You can't divide them all by 3. This is the lowest coefficients I could possibly have. All right, so that's number 3 on page 1. Let's do number 5 on page 1. There we go, number 5. So number 5. I'm going to start off like I usually do. Oh, that's too big. That's too big. That's not good. I'm going to start off like I usually do. I'm going to draw some columns down here. And then I'm going to count what elements I got. I have a sodium. So that's Na. I have another sodium. I have nitrogen. Capital N. And I have oxygen, or O. And if I want to double check, I have oxygen on this side, I have nitrogen right here, and I have sodium right here. Okay, so right off the bat, I can see I have sodium in 2 different spots here. So I'm saving it for last. Again, sodium's here by itself anyway, so it's good to save for last. So now let's count what we got. I have 1 times 1 sodiums and 1 times 1. So I have 1 plus 1, which is 2 total sodiums on the left-hand side. For nitrogen, I have 1 times 1. I only have 1 nitrogen. For oxygen, I have 1 times 3 total oxygens. On the right-hand side, I have 1 times 2, I have 2 sodiums. I have 1 times 1, I have 1 oxygen. And I have 1 times 2, I have 2 nitrogens. So sodium is actually balanced. So I'm going to ignore sodium for now. I see nitrogen by itself right here. Maybe I'll save that for last. Let's just save that for last. And so I'll move on to oxygen. Oxygen is not by itself. It's only one molecule. That's a good place to start. So let's start here. Oxygen, I have 1 on the right side. This is my lowest number, so I want to increase the amount of oxygens on the lowest side. I know I want to try and get the same as my other side, so if I put a 3 here, that'll give me 3 times 1. That'll give me 3 oxygens. It'll balance my oxygens. But it'll also change my sodium. So now I have 3 times 2 sodiums. I have 6 total sodiums now. Sodium is not balanced. And, okay, so there's a mistake we can make here, right? If I put a 6 here, that'll give me 6 sodiums, which could be good. However, I'll have 1 sodium here, that'll be 7, so we don't want more than 6 sodiums, we want 6 sodiums. So some people would put a 5 here. Now the problem is if I put a 5 here, let's just do it real quick and see what happens. If I put a 5 here, yes, that'll give me 5 times 1 plus 1, that'll give me 6 sodiums, it'll balance my sodiums. But it'll also give me 5 times 1, it'll give me 5 nitrogens. And if I look over here on the right side, nitrogen is written as N2. So it can only increase by values of 2. So I do not want an odd number of nitrogens on the left-hand side. Something I can do, though, I can put a 4 here. Right? And the 4 here won't necessarily balance my sodiums. Right? I'll have 4 times 1 plus 1 times 1. That'll give me 5 total sodiums. But what can I do to get myself 6 sodiums? I could also change this number from a 1 to a 2. And so that'll give me 2 times 1 plus 4 times 1. That'll give me 6 total sodiums. And since I changed everything on the left-hand side, I'm just going to recount everything on the left-hand side. 4 times 1, now I have 4 nitrogens. And 4 times 3, now I have 12 oxygens. And now I'm getting a little scared because I know that this is a really big number. But I'm just going to keep going. Maybe I made a mistake, but if I made a mistake, you just keep moving on until you get everything eventually balanced. Once everything's balanced, then you can go ahead and reduce it. So let's go ahead and balance our oxygens again. Oof. Okay, let's balance our oxygens again. We have 12 oxygens on the left-hand side. I want 12 oxygens on the right-hand side. So in order to get 12, I'll put a 12 here. Delete this. We'll put a 12 here. And that'll give us 12 times 1. That'll give us 12 total oxygens. That'll also change my number of sodiums. I'll have 12 times 2. So that'll give me 24 sodiums. And then let's go ahead and balance oxygen. No, oxygen's good. Let's go ahead and balance sodium. Now, if I balance sodium, this is what I did before, right? I added a few here and I added 1 here. That didn't seem to work out for me. So let's see what I can change this to. I'm going to change both of these numbers, actually. I want to change both these numbers in a way that'll give me 24 sodiums and 24 sodiums and only 12 oxygens, right? So, okay, so that's not bad. So I'll have 4 here. That'll give me 4 times 3. That'll give me 12 oxygens. It'll also give me 4 times 1. It'll give me 4 sodiums. Now, in order to get 24 sodiums, I need to put 20 over here. That'll give me 20 times 1. That'll give me 20 total sodium. So 20 times 4 is 24. And now I can balance my nitrogen because I have 4 times 1, I have 4 nitrogens. So in order to get 4 nitrogens on this side, I will put a 2 here. And that'll give me 2 times 2, which will give me 4 total nitrogens. And now I can see everything's balanced, 24, 4, and 12. Right? Now these are really big numbers, but the equation balanced out. Now, is this my final answer? No, this is not my final answer. I could already tell because, let's erase all this writing. I can tell this is not my final answer because all of those coefficients are reducible. So I definitely made a mistake somewhere. I overstepped, I overbalanced, but I'll show you why that's not a problem. Right? I have 20, I have 4, I have 12, and I have 2. What can I divide all of these by to get evenly? So I can divide 20. I can divide them all by 2. 20 divided by 2, 4 divided by 2, 12 divided by 2, and 2 divided by 2. That'll leave me with 10, 2, 6, and 1. So I'll erase all this. I'll write the coefficients as 10, 2, 6, and 1. And there you have it. That's your final answer. Right? Do you guys see how I made a mistake? However, I just kept going until everything was balanced. I realized my mistake. I didn't make the same mistake over and over and over again. And then I was able to successfully balance the equation after reducing it. So let's move on to the other sample problem, number 6. I probably should have done these in order from hardest to easiest, but I didn't, so there. All right, so first thing we want to do is we want to count our molecules. We know we have a carbon, so we'll put a C here. And we know we have a sulfur, so we'll put an S here. On the right-hand side, yes, we have sulfur, and yes, we also have carbon. Now let's count. We have 1 times 1, we have 1 carbon, and we have 1 times 8, we have 8 carbons. On the right-hand side, we have 1 times 1, that's 1 carbon, and we have 1 times 2, that's 2 sulfurs. My carbons are balanced, so I'm just going to go ahead and balance my sulfurs. In order to have 8 sulfurs on the right-hand side, I would know I would need 4 times 2, which is 8 sulfurs. Right? And everything looks balanced. I can stop, right? No, because changing this coefficient, it changes everything in that molecule. So yes, I have 8 sulfurs, but now I have 4 times 1. I have 4 total carbons. So carbon is not balanced. So now I need to go over here and balance carbon. I know if I change this to a 4, I'll have 4 times 1. I'll have 4 total. 4 total. I don't want you to do that. I should do this. Cross it out and then write the new number. I have 4 total carbons, and now I can see everything is balanced. And then you want to ask yourself, are all these reducible? Can I divide all these numbers by the same thing? And the answer is no, you cannot. 1 does not divide evenly by anything at all, unless it's a 1. And that's it. If you guys have any more requests for practice problems, just let me know. You can ask me specific problems if you want, and then I can go over those and post the video. Bye, have a great day.